In this video, I'm going to teach you how to calculate the change in enthalpy for a chemical reaction using something called the standard enthalpy of formation. Because this is the first time I'm talking about standard enthalpy of formation, I'm going to begin by defining exactly what it means. This is the notation that we use to describe or to indicate the standard enthalpy of formation. And the standard enthalpy of formation is just a special version of an enthalpy of reaction, which you're familiar with. So the enthalpy of a chemical reaction is just describing the heat that is exchanged in a chemical reaction. If the reaction is special, we can give it this special designation, delta H of formation. In order for us to call the delta H of a reaction delta F standard, the reaction has to meet two conditions. Number one, the reaction has to be held under what we call standard conditions. Standard conditions put restrictions on the temperature and the pressure of the chemical reaction. Specifically, the reaction has to be held at a constant pressure of 1 atmosphere, and it has to be conducted at a constant temperature of 25 degrees C. So again, in order for the enthalpy of a reaction to get this special designation, delta H formation, it has to be held under these very restrictive temperature and pressure conditions. The second criteria that we have to meet is that the reaction needs to describe the formation of a molecule from the elements in their natural state. So it can't just be any chemical reaction at all. It has to be a chemical reaction that describes the formation of a molecule from its elements in their natural state. For example, if we wanted to write the standard enthalpy of formation for the formation of carbon dioxide, CO2, we would need to show the reaction as being the formation of carbon dioxide from its elements, carbon and oxygen, in their natural state. The natural state of oxygen is O2 gas, and the natural state of carbon is graphite. So if we were to perform this particular reaction, as long as we kept it at 1 atmosphere and 25 degrees C, because this reaction describes the formation of carbon dioxide gas from its elements in their natural state, the change in enthalpy for this particular reaction could be given the special designation delta H of formation standard. That little looks like a degrees symbol is what we use when the reaction is held under standard conditions. The enthalpy of formation values are typically associated with molecules, not with a chemical reaction. So if you go to your textbook in the appendix, you'll find a data table full of delta H formations for a whole bunch of different molecules. For example, I've listed 3 of them right here. If you go to your textbook, to the back of your textbook, you could look up all 3 of these molecules and you would find that there are delta H values for all of them, plus a whole bunch more. If you don't have a textbook, you can find standard enthalpy of formation values on the internet. Just Google it and there will be tons and tons of data tables available for you. Now, the way that you can use these delta H of formation values is to calculate the standard enthalpy of reaction is a derivation or a version of Hess's law. And how I'm going to write this up, initially I'm going to write a generic chemical reaction. So this would be molecule A reacting with molecule B to make molecule D and molecule E. And the little letters that I'm putting in front here, these are meant to be the stoichiometric coefficients for each one of these molecules. So if we wanted to use delta H of formation to calculate the change in enthalpy for this entire reaction, so this would be the change in enthalpy for the reaction, what we would do is go to our data table and we would look up the standard enthalpies of formations for all 4 of these molecules. We would take the stoichiometric coefficient of molecule D and we would multiply that by the standard enthalpy of formation for molecule D. And we would add that to the stoichiometric coefficient of molecule E multiplied by its standard enthalpy of formation. And this gives us the standard enthalpy of formation for all of our products. From that, we are going to subtract the standard enthalpies of formation for all of our reactants, again, each one being multiplied by their stoichiometric coefficient. When we look at the formula, in this particular format, it kind of makes it seem like it's a pretty complicated calculation, but it's actually really straightforward. So let's take a look at this example right here, where we're actually going to apply this version of Hess's law. We have this chemical reaction right here. We're being asked to calculate the delta H of this reaction using these standard enthalpies of formation. So looking at this formula right here, the first thing that we have to do is focus on our products. We have to use the enthalpies of formation for each product multiplied by the stoichiometric coefficient for each molecule. This particular reaction, everybody's stoichiometric coefficient is 1, which is going to make it that much easier for us. The standard enthalpy of this particular reaction is going to be the stoichiometric coefficient, 1, times the enthalpy of formation for MgO, this guy right here. And as we're doing this, we want to make sure that we don't make any changes to the signs of the delta H of formation. So if they're positive, keep them positive. If they're negative, keep them negative. We're going to multiply this, or add this to the standard enthalpy of formation for our second product, H2O, which is negative 285.8 kilojoules per mole. And this is the standard enthalpies of formation for both of our products. From that, we are going to subtract our reactants, magnesium hydroxide, there's only one of them, and the standard enthalpy of formation for this guy, negative 924.66 kilojoules per mole. We do the math out on this, and it works out to be a positive 37.1 kilojoules per mole. Because this particular delta H was calculated using standard enthalpies of formation, we can also call this delta H of reaction a standard delta H of reaction. The mantra, or the thing that I want you to remember when you're using this particular method, is products minus reactants. Taking the delta H of all of our products and subtracting the delta H of all of our reactants.